Hello guys, welcome to our video for today. Today we're officially starting with our first chapter of geometry, chapter 1-1, and we are covering understanding points, lines, and planes. The objective for today is for us to identify, name, and draw points, lines, segment, rays, and planes, as well as apply basic facts about points, lines, and planes. Now for this section, guys, there's a lot of vocabulary, so go ahead and take out your geometry notebook and write down the definitions as we go along, as well as the examples that we're going to go through. Okay, so make sure you're writing down the definitions because there's a lot of definitions in this section. All right, so the most basic figures in geometry are what we call undefined terms, which means that they cannot be defined by using other figures. These undefined terms are points, lines, and planes, and they are the building block of geometry. So basically, without points, lines, and planes, there's no way we can create the world of geometry that we have. So they are the building blocks of geometry: points, lines, and planes. And so what are points, lines, and planes? I mean, I'm pretty sure we all have a basic idea of what they are, but in geometry, we need to know the exact definition, and we don't know, and we need to know how to name each one. Okay, so a point is a name. Is a point named a location and it has no size. It is represented by a dot. So we all know that a point is we use a dot to depict what a point is. But in order for us to name a point, we must use capital letters to name a point. We must use capital letters to name our point. If I were to have another point here, I would name that point with a capital letter such as point Q. Or if I write another one here, I can name that with a capital letter R, or so on and so forth. Again, when we name a point, we must use capital letters. A line is a straight path that has no thickness and it extends forever. This right here is a key word for a line. For a line, it extends forever. All right, so for example, here we have a line here and it has these two arrowheads. These two arrowheads are telling me that the lines don't just stop here. These lines keep going forever in this direction, and this line keeps going in this direction forever and ever and ever. So would you believe me if I told you that this line right here is actually the longest line in the world? Yes, because again, this right here doesn't, these arrows right here tell me that these lines keep going forever and ever. They never stop. So the line is a straight path that has no thickness and it extends forever. Now, in order for us to name our lines, we use either a lowercase letter. For example, here we use lowercase l, or 2 points on that line. So for example, here we have these 2 points on that line, point X and point Y. We can name a line either by a lowercase letter or by any 2 points on that line. So for example, here we have line XY, and we use a line with the 2 arrowheads on top to name it, or it can be line YX. The order doesn't matter as long as you pick any 2 points on that line. So for example, if I had here another point Z, this same line could also be called oops, I don't know why that's doing that. Let me see. Again, if this was point Z, then, oh my God. If this was point Z, this line could also be called line XZ. And again, we use the line with the 2 arrowheads, or this can also be line YZ. Again, any 2 points on that line can be used to name that line. And again, the order doesn't matter because it doesn't have a specific direction that it's coming. And lastly, a plane is a flat surface that has no thickness and it also extends forever. Right, so usually in geometry, to draw a plane, we tend to draw a slanted rectangle like such. Right, and so to name our plane, we use either a script capital letter, for example here, capital script R, or any 3 points that are not on a line. So in this case, we have these 3 points, A, B, and C. So to name our plane, we can either name it as plane with the script R, or plane A, B, C, any 3 points on that plane that are not on the same line. Okay, so if I had any other points, for example, let's say I have point D here, this plane could also be named plane by any 3 points on that plane. It can be plane A, D, C, or plane B, D, C. Again, you can pick any 3 points on that line as long as those 3 points are not on the same line. Right, so that's what a point, line, and plane are. Now this says here, points that lie on the same line are collinear. And so what does collinear means? It means any points that lie on the same line, where co stands for same and linear stands for line. So any points that lie on the same line, they're called collinear points. So for example, here, point K, point L, and point M, these right here are all collinear points because they lie on the same line. Unlike if I were to look at points K, L, and N, these would be non-collinear points because they're not on the same line. That's what non-collinear means. Non-collinear means the points that are not on the same line. So for example, here, K, L, and N. Then it says points that lie on the same plane, those are called coplanar. Again, we said co stands for same, and planar stands for plane. So any points that lie on the same plane, they are called coplanar. Otherwise, they will be called non-coplanar. So for example, here, point K, N, L, and M, they're all coplanar because if your computer screen or your phone screen will be the plane, they all lie on the same plane. Unlike if we were in school, if we were all in our classroom, all of us will be coplanar because we'll all be standing on the same plane. We'll all be standing on the same ground. Unlike if it was us compared to the people that are in the second floor, we will be non-coplanar because the people on the second floor are on a different plane. So that means that we will be non-coplanar because we're not standing on the same plane. All right, so let's try these examples right here. It says example number 1, they want us to name 4 coplanar points. Again, what do we say coplanar meant? Co means same, and planar means plane. So they want us to name 4 points that are on the same plane. So in this figure here, we have 5 points. We have point A, we have point B, we have point C, point D, and point E right here. Where all these lines intersect, that's point E right there. So which 4 points from here are coplanar? In this case, the only one that is non-coplanar would be point E. This one will be non-coplanar. Why? Because it's not on the same plane. This one is floating up there. So the 4 points that are coplanar will be point A, B, C, and D. These points will be coplanar because they all lie on the same plane. Example letter B, let me go ahead and erase this. For letter B, they want us to name 3 lines. So if you see here, I have a total of 4 lines. I have line AE. Okay, this is pretty slow. Line AE. And then I have line BE. I have another line here, line CE. And lastly here we have line DE. We have these 4 lines right here. And so they want us to name any 3 of them. So in this case we have, I know I have line AE. Oops. I know I have line AE. And again, in order for us to name a line, we use line with the 2 arrowheads, which is line AE. Which one's the other one? We have line BE. The other line that we have is line CE. And might as well name the 4th line. In this case will be line DE. Again, in this case, it doesn't matter. This one could also have been line EA. They were talking about the same line here. It's just the order doesn't matter. It doesn't matter if you put the A or the E first because, again, there's no direction there. It's both extending forever and ever and ever. So if you want us to name here 3 lines, we have these 4 lines in total. Now, I'm pretty sure some of you guys are wondering, why isn't this right here, BC or AB? Why aren't those lines? They're not lines. They're called something else. And in a little bit, we'll cover what those parts of lines are called. Okay, but those are not lines because again, lines, what do I know about lines is that they extend forever and ever and ever on both directions. For lines, they have to have the 2 arrowheads on both sides. All right, what about this example here? They want us to use a diagram to name 2 planes. As you can see here, I have this first plane right here and the second plane right here. If we look at the first one, in order for us to name a plane, all we need is any 3 non-collinear points. So we have point A, B, let me use a different color. We have point A, B, and C. And since these 3 points are non-collinear, then that means we can pick those, plane A, B, C. Or again, the order doesn't matter here. This one could also be called plane C, B, A, so on and so forth. As long as those 3 points are not on the same line, as long as they're non-collinear, you can pick those 3 points to name a plane. Or for example, here, the second example here, we have 4 points. Again, in order for us to name a plane, all I need is minimum 3 All I need is 3 points to name our plane. So in this case, this can be called plane KLM or plane LMN, so on and so forth, as long as you have 3 non-collinear points. Or if we have a script letter, this can also be called plane fancy R. Could have done a better job, but that's a fancy R. Plane R as well. Those are different ways we can name the planes that we have here. Now here we have a couple more vocabulary. The first one here is a segment or a line segment is a part of a line. This is a keyword here. A segment is a part of a line consisting of 2 points and all points between them. So here, right here, the difference between a segment and a line is that a segment has a start and it has an ending. It's a part of a line. Okay, and in order for us to name our segments, we just use the 2 endpoints. It can be called the segment AB, and notice how the figure on top, we just use a straight line with no arrowheads because this one doesn't have no arrowheads. So it can be called segment AB or segment BA. So again, a segment is a part of a line. This has a start and it has an ending. That means that it has 2 endpoints. And an endpoint is a point at one end of a segment or the starting point of a ray. So in order for us to name our endpoints, again, since they're points, we use capital letters. So this will be point C and point D. Now a ray is a part of a line that starts at an endpoint and it extends forever in one direction. So a ray has a starting point and then it goes in one direction forever and ever. Okay, so to name array, this one we do have to be very careful when we're naming array because the first letter always has to be the endpoint first. Okay, so in this case, let's look at this ray, for example, here. We start at point R and it goes in the direction of S and it extends forever and ever. That's right there is a ray. So we start at point R and it goes in the direction of S. And to name it, we always use a line with only one arrowhead pointing to the right because this is telling me that we're starting at point R. This one's naming this as well. We're starting at point R and it's going in the direction of S. Even though we're going to the left here, we always put the arrowhead pointing to the right. So this right here is ray RS, where we start at R and we go in the direction of S. For ray, the order is very important when you're naming a ray. The first letter has to be the endpoint first, where we're starting. And so lastly, opposite rays are 2 rays that have a common endpoint and they form a line. So as you can see here in this figure, we have 2 opposite rays. The first ray here, we start at E and it goes in the direction of F. So as you can see here, we start at E and it goes in the direction of F. That's ray EF. And the opposite ray starts at the same endpoint. It starts at E and it goes in the direction of G. So this right here, we have 2 opposite rays. And when you have 2 opposite rays put together, they form a line. Because as you can see here, now we have the 2 arrowheads on both sides. So 2 opposite rays form a line. So you can see here, ray EF is the one going to the left, and ray EG is the one going to the right. Again, the first letter always has to be the endpoint first. We start at E, and we go in the direction of F, and we start at E, and we go in the direction of G. All right, so let's try these examples here. So example letter A, they want us to draw a segment with endpoints M and N. So what did we say a segment was? This was a part, a segment is a part of a line. In this case, a part of a line. So if it's a part of a line, that means it has a starting point and it keeps going and it has an ending point. And so the endpoints, I want us to name them endpoint M and endpoint N. In order for us to name our segment here, remember it has to be the endpoints MN with only a line on top. And again, for segments, the order doesn't matter. This one can also be called NM. The order doesn't matter for a segment. Part B, they want us to draw opposite rays with a common endpoint T. Okay, so they want us to draw opposite rays. I'm going to draw my first one here, starting with the common endpoint T. And if I go in this direction, this is my first ray, and the opposite ray has to start in the same point, point D, but then go the opposite direction. In this case, it goes this way. So this right here, we have 2 opposite rays with a common endpoint T. So if I were to add a point here, let's call this point R. And if I were to point a point here and put this S, that means that my green ray right here, remember, in order for me to name it, it has to start at T, and it goes in the direction of R. And my other ray, again, the other one to name it, we start at T, and we go in the direction of S. This is how we name our two rays here. And since they're opposite rays, together they form a line. Right, so part C here, they want us to draw and label a ray with endpoint M that contains N. So, okay, so if I have a ray, start has an endpoint M, and somewhere along the way, along my ray, contains point N. So somewhere in here, there's a point, and it's called the N. So this right here, we have a ray that has the endpoint M, and it goes in the direction of N. So in this case, to name my ray, remember my first letter has to be my endpoint, and the second one has to be any other point on that ray. And the arrowhead always points to the right. All right, so a postulate or axiom is a statement that is accepted as true without proof. Postulates about points, lines, and planes help describe geometric properties. So postulate is something that is true regardless. Like it just makes sense. We don't have to prove it. That it's just that it's just true. So let's look at these couple postulates that they're giving us here. The first one tells me that through any 2 points, there is exactly one line. So no matter if I draw any 2 points, let's say this one here and this one here, there's only exactly one line that's going to go through those 2 points. That's what the first postulate is telling me. The second one tells me that through any 3 non-collinear points, there's exactly one plane containing them. So if I were to draw any 3 points, let me draw them over here. Point A, point B, and point C, as long as they are 3 non-collinear points that are not on the same line, if you have any 3 non-collinear points, there is exactly one plane, because if I were to connect these, I would already make a plane here. And lastly, the third postulate tells me that if 2 points lie on a plane, then the line containing those planes lies on that plane. So for example, like if we were to look at this first example, if your screen or your phone screen or your computer screen is a plane, remember a plane is any flat surface, this point is lying on your screen and this point is lying on your screen, then obviously this line that's going through these 2 points is also lying on your screen. So in this case, obviously it also will be containing, it says if 2 points lie in a plane, then the line containing those points also lies on that plane. So this line is also on that same plane. All right, so let's see. It says name a line that passes through 2 points. So right here on my plane, I have these 2 points, this point and this point, and they want me to name a line that goes through those points. And again, in order for us to name a line, all I need is to pick any 2 points on that line, so X, Y, and we put the line with the 2 arrowheads on top. Or again, this one also could have been named YX. The order doesn't matter here. As long as it has the 2 arrowheads on top, that's how we name our line. Example number 4, they want us to name a plane that contains 3 non-collinear points. Again, remember, non-collinear means points that are not on the same line, not on the same line. All right, so I have here point G, point H, and point F. Again, this lowercase n, remember, lowercase n is used to name a line. So that letter is not a point, because remember, to name a point, we need to use capital letters. Lowercase letters to name the line. So if you want us to name a plane, in order for us to name a plane, we can just pick any 3 non-collinear points. So this can be named plane G, H, F. Or again, the order doesn't matter. This could also be called plane H, F, G, or so on and so forth. As long as I pick any 3 points on that plane that are non-collinear. So for example, if I were to have here point P, I cannot name my plane. Oops, I forgot my E. If I had to point P there, I could not name my plane GPH. That would be completely wrong. Why? Because these 3 points lie on the same line. Again, in order for us to name a plane, they have to be 3 non-collinear points. So that will be incorrect. Right. So again, remember what we said, a postulate was something that we just accept that it's true without proof. We have 2 more here. It says that if 2 lines intersect, that they intersect at exactly 1 point. So if I have 2 lines that intersect, let me go ahead and draw 2 lines. So I have one here, and they intersect. That means that they cross each other. Let me pick a different color here. Or to have 2 lines crossing each other, then when those 2 lines cross each other, they intersect at exactly 1 point. So when they intersect at exactly 1 point right here. That's what that postulate is. Pretty common sense, right? If 2 lines intersect, then they intersect in exactly 1 point. The second postulate here tells me that if two planes intersect, then they intersect in exactly one line. So if we were to be in our classroom, if I were to have my front wall with my side wall, when they intersect at exactly one line. So let me try to draw this out for you. So I have my wall here, and I have my other plane, and it's going to intersect that wall. As you can see here, they intersect at exactly one line right here. That's what that postulate is telling me, that when two planes intersect, they intersect at exactly one line. So the first one says if two lines intersect, they intersect at exactly one point. If two planes intersect, then they intersect at exactly one line. That's what these two postulates are telling me. All right, so then here, example number 5, they want us to sketch two lines intersecting at exactly one point. All right, so just how we had seen right here, we have two lines that intersect, and they intersect at exactly one point. And part B, they want me to sketch a figure that shows a line that lies on a plane. So as you can see here, we have our plane, and we have our line that is lying on top of it. All right, so in this case, again, even though it has the arrowheads, remember a plane extends forever and ever and ever, so does our line. So our line is lying on that plane as well. And lastly here, they want us to sketch a figure that shows two lines intersecting at one point in a plane, but only one of the lines lies on that plane. Okay, so let me try my best to draw this out for you. So I have a plane, right? I'm just gonna draw my plane like this. It's telling me, sketch a figure that shows two lines intersecting and one point in a plane, but only one of the lines is on the plane. So we have one line here that is on my plane. That means I want to have another line that's going to intersect this line, but it's not on the plane. So how will we draw that? It will draw it like this. I have one line that's coming down. It intersects that plane at this point, but then it goes through the bottom of that plane right there. That's basically what this means here. That means that this line is on that plane, but this line is coming from another direction. It intersects, and it goes through the plane right there going through. If I were to put a better drawing for you, it would be in such as this. The plane, where we have the line right here. We have our line right here, and then this line is coming from a different direction. It intersects, and then it goes through the plane there. And so in this case, we use a dashed line to show the hidden parts of any figure that you are drawing. And dashed line will indicate the part of the figure that is not seen. So in this case, basically, we're not seeing this part here because it will be under the plane. But we use it dotted so it can indicate that it's going through the drawing. All right, so let's try these examples. Now, these examples are going to be very similar to the ones that are going to be in your assignments. So the first one here, they want us to name line CE two other ways. So let me see. Line CE is right here. Line CE is this line right here. And they want us to name it two other ways. So remember, in order for us to name a line, all I need is to pick any two lines on that plane. on that line. So in this case, name line CE, we have another point B. So this same line can also be called BC, lines BC or CB. Or what other way can we use? It can be also line EB. Again, you can name it many ways as long as you pick any 2 points on that line. And again, the order here doesn't matter. So it can be CB as well, line CB or line BE. All right, example number 2, let me go ahead and erase this here. Example number 2, they want us to name the opposite rays on line CE. So remember, we have opposite rays, and they have the same starting point. So in this case, the same starting point would be at point B. So my first ray will start at B, and it goes in the direction of C. So right there is my first ray. In order to name our ray, we start at the endpoint B and goes in the direction of C. Remember, the arrow always goes to the right. And the opposite ray, again, the opposite ray starts at B as well, and it goes in the direction of E. So right here we have our two opposite rays, which again, the second ray will start at B, and it goes in the direction of E. So this right here, we have our two opposite rays on our line CE. They start at B, and they go in opposite directions after that. Okay, number 3. They want us to name the intersection of segment DB. Remember, since there's no arrowheads, I know it's a segment. Segment's DB, which is this one right here, and line CE. So where do they intersect? Where does segments DB intersect on line CE? In this case, they intersect at point B. They intersect at point B. Number 4, they want us to name plane W 2 other ways. So again, in order for us to name a plane, all I need is any 3 non-collinear points. So in this case, can I name it plane CBE? Can I name it plane CBE? No, exactly. I cannot name it plane CBE because, I mean, they are 3 points on the plane, but they must be non-collinear. They cannot be on the same line. So in this case, in order for me to name my plane, I can name it plane CBD, because again, those 3 points are non-collinear, or as well as plane EBD, or again, any 3 points that are non-collinear. And lastly, part number 5, they want me to name 4 segments. Remember, segments are parts of a line where they have a start and they have an ending. So let me go ahead and erase this right here. So my very first segment, the very first one that I know is segment D, B right here. I have a starting point and an end point. So my first segment here is segment DB. What other segments do we have here? Another segment that I can have here is segment C, and it goes to B. That's another segment there, CB or BC. Again, the order doesn't matter. What other segments do I have here? I have segments E, and it goes to B, or again, BE, doesn't matter. Another segment would be BE. And I have one more segment. What segment would that be? My last segment here can be starting at C, and it goes all the way to E. That's my last segment here. Starts at C, and it goes all the way to the direction, all the way to E. Those are my 4 segments. I'm not sure if you can see the yellow, but the yellow will be CE, segment C. Those are the 4 segments that I have in my drawing here. All right, lastly here, I want you to go ahead and try these problems on your own. They want you to identify each figure as a point, a segment, array, a line, or a plane, and they want you to name each one. So for example, I'm gonna do one example for you, and then I'll let you try the rest on your own. So for example, here, let's do number 3 here. What is this right here? Now look at it specifically, there are 2 arrowheads. So what do I know if it has the 2 arrowheads? What do I know it is? Is it a segment, array, or a line? Remember, exactly, this one here has to be a line because the line extends forever in both directions. So this will be a line. And so now how would I name my line? With any 2 points on that line. So in this case, it can be line CD with the 2 arrowheads on top, or this can also be line DC. The order doesn't matter there. So that's what they want you to do for all of these problems. You should go ahead and put pause and try to answer all of these problems, and then we'll go over it together. Okay. So for the first one, very easy. Obviously, what is this right here? This is a point. And to name it, this is a point. And to name it, obviously, we just use a capital letter. So this will be point, and this will be point L. Number 2 here, what is this called? This will be a plane. And again, in order for us to name our plane, all we need is any 3 non-collinear points. And since these 3 points are non-collinear, this can be called plane L and M, or plane M and L. Again, the order doesn't matter in this case. So many of you could have gotten different answers here, but as long as the points are non-collinear, you can name it with any 3 points on the plane. Number 4 here, what is this? It has a starting point and an end point. Is it an array, a line, or a segment? Exactly, since it has a starting point and an end point, it's a part of a line. That means this will be called a segment. And so to name our segments, we just need our 2 endpoints. In this case, it will be segments PO with just 1 line on top with no arrowheads, or OP. In that case, that's how we will name our segment here. Number 5 here, okay, so I have 2 arrowheads. So what did we say this was going to be called? If it has 2 arrowheads, means that it extends forever on both directions. That means it's a line. And so to name our line, here we have 3 points. But in order for us to name our line, all we need is 2 points on that line. So in this case, this can be called line EF, or FG, or EG. Again, there's many ways we can name this line because all we need is just to pick 2 points on that line to name it. And lastly here, number 6. Okay, so number 6, I notice I have 1 starting point, 1 end point, and it goes in 1 direction only. So in this case, what would this be called? This would be called array. And so now for array, remember that you have to be very careful when you're naming it. What has to be our first letter here? Our first letter has to be our endpoint. So in this case, our first letter has to be S, and our second will be T. And again, the arrowhead always goes to the right because this is telling me that we're starting at S and we're going in the direction of T. So in this case, it will be Ray as T. Right, so thank you so much for watching my video. If you have any questions, go back to our Zoom meeting during class time, work on the assignment posted on Google Classroom, and if you have any questions, feel free to ask me.